Alright guys, just a quick video to demonstrate modifications to the Razor Dirt Quad. What I've done is I've added from monsterscooterparts.com, I've added a 1000 watt 36 volt motor, and I did that by making a custom, actually my father, who's a machinist, made this for me, but it's a custom mounting plate. It didn't require any welding or modifications back here. The plate mounts to the swing arm using the factory holes, and then the motor mounts to the plate. And the reason you need that is that this motor's longer, and so right in here it gets really close to the brake caliper. You can see there's space in there now, but it gets really close to the brake caliper, so you have to shift from the factory motor location. It has to be pushed out a little bit. Now the way to do that over here, this is the original sprocket hub. This is a different sprocket on it, but the hub is the original one. The long part right here that goes up against the bearing right there was on the factory model on the other side. So you just take this off. You can see the key sticking out right there. You just take that off, flip it over, and that moves the sprocket out, and it moves it over just enough to align there with the drive sprocket and get it away from the brake caliper over here. You don't have to change the keyway or anything like that, just flip it over. And then this gear also available on I think I got that one at electricscooterparts.com, but I think it's available at Monster also. That's the biggest one they had, and it just mounted right up to the factory sprocket hub, which is fantastic. And then over here I did have to make a little spacer. That's a little brass spacer that's right in there to move the brake disc over just a little bit, because even with this, we had to make spacers to go underneath the brake caliper to move it out just a little bit. And those are real simple. They're just like, you could stack washers behind where it mounts to the little bracket right there. That's the screw. That's the spacer right there, but you could stack washers in there if you don't want to make a spacer and that kind of thing. Same thing down here. You could just stack washers in there to move it over just a little bit. Now, we could have just moved the motor over a little bit more with the plate, and we wouldn't even have had to fool with this at all. But, you know, when you're making this kind of stuff, you make the plate, you test fit it, and you realize it didn't fit exactly like we wanted it, and then, you know, that's why we spaced that over. That was the easiest thing to do. Now, this is a custom axle. I actually ordered the steel from McMaster Car. They had the right diameter and all that, and then just cut it down to the right length. I actually wish we hadn't done that. I did it so because of the extra speed, you know, it would be more stable in terms of flipping over, but really all that's done is it's made it more difficult to turn, because there's no differential, so the greater the distance between the wheels, the more that locking effect, you know, you have when you turn these things, because one wheel's on the inside diameter, one wheel's on the outside diameter, so it basically locks it in place. Not really a problem in the grass, but it is a problem on the road, and it does wear the tires faster, because in a turn one tire is always slipping then. So I just regret doing that. I wish we hadn't made the custom axle, and if I was doing this again, we wouldn't do that. So it's wired to it was a kit. The motor, the speed controller, and the throttle all came as a kit, and this is on slots. The motor's on slots, so it can adjust the chain tension. You can see it probably needs some adjustment now, but it is on slots, so you can do that. That's three 12-volt batteries wired up to make 36 volts, and then I just wrapped them in Gorilla Tape to sort of make them one unit in there. The wiring's really simple. It uses the factory charging port right here. And if you've not ever wired that, if you're looking at this video trying to figure out how to do it, it's really simple. You just use a multimeter and you figure out where the positive comes out of the charger, where the negative comes out of the charger, and then you just run that to the positive on the battery and the negative on the battery. It's that simple. It doesn't go through the speed controller or anything like that. It doesn't create any issues. It's just positive out of the charger, which is a $15 charger from eBay. I'm not even sure it was that much. 15 you know, scooter 36 volt charger, uses the same plug and everything. Now honestly, I can't remember if I ordered it that way or if I had to if I had to cut it off and put an end on it, but it doesn't matter. You're just running positive to positive, negative to negative. Way to think about it is you could take the 2 wires coming out of the charger and just run them straight to the batteries. That's what all you're really doing here with the plugs. You have to, don't make that more complicated than it is. The only part that really required, the expertise other than the plate would be this battery tray right here. That's a custom tray. We just had to extend the tray forward, so we just cut the old one off with a grinder and welded a new plate on there. So the welding is the part, a lot of guys might not be able to do. Now that's not completely necessary, because the old battery tray, you'd have to flatten out this edge. You just bend the edge down, and then the front battery would not be totally setting on the tray. You'd flatten that edge too, and that battery would be forward to the edge of the tray, but it would still be sitting on this bar, and the other batteries would keep it from rocking side to side. So as long as you wrapped it real tight with the Gorilla Tape like I did, and then you strapped them down, I don't think there'd be any issues, and you wouldn't have to make that battery tray. This is probably better, really long term, but not necessary. So the question is, how does it perform? With my 170 pounds on it, well, it's geared now for 15 miles an hour. The factory setup was geared for 10 miles an hour. This motor and its RPMs, given this gear ratio here and the size of the tires, it should be right around 15 miles an hour. It'll do that, on flat land. With my 170 pounds on it, it gets up close to 15 miles an hour, which is almost scary fast on this, because any little turn in the wheels makes it feel like it's going to flip over. So it doesn't go that fast, of course, in the grass, but on the pavement it will. And then riding around my backyard, it's hard to see, but this is all, on the video, this is all a pretty good slope. And like down there at the drainage pond, that's a really steep slope down there, and it will pull my 170 pounds right up all of the hills in my yard without stalling like the factory setup would do. The motor would stall. Even with the gear reduction, it would stall. It's fun. My kids right now won't ride it because they're afraid of it, because it has a lot of torque, so it takes off really fast. And of course the throttle allows you to keep that from happening, but the kids haven't learned that yet. So if you have any questions about how it was made, or where to get the parts or anything like that, let me know. I'd be happy to help you.